We have Rob Pickering here with us today. He is the founder and CEO of IP Cortex. He has been a lifelong advocate of open source software, all near and dear to the hearts of everyone in this room. He describes himself as a recovering software engineer. He'll tell us in a moment what that means to him. He's worked on TCP IP stacks since the 1980s and through into web and VoIP systems, including with WebRTC. He says that he developed a mobile SIP client in just 6 months. In 6 months, you know, I've developed SIP clients. I know exactly how hard that is, and that's crazy. He did it in 6 months using WebRTC and JS SIP with React Native. The title of his talk is Rapid Development of Efficient Mobile Clients, on which he is an expert. Let's give a big round of applause to Rob Pickering.
Thanks, folks. So yeah, we went off and developed a mobile client, and I guess the first question you've got to ask is, who in their right mind would do that, right? Why would you go off and decide to develop a mobile client? Because they're not exactly easy things to do. And I guess the reason for that is that mobile clients, I think, are increasingly important. So they're becoming the primary interface that people use services. I think particularly in SMEs, we're past peak desk phone now, right? And most mobile apps really don't work as well as the built-in mobile app on a phone. I run a VoIP company. We work in a barn in the middle of nowhere where we've got gigabit fiber connectivity. And we put a picocell into there to get some decent mobile connectivity, because people, by default, me included, pick up their phone and they go for the native built-in client because it just works and it's nice and clean. And it doesn't suffer from some of the problems that we tend to have when we go off to build SIP mobile clients. And that's a huge wasted opportunity, because the ability to get your platform features, the things that are important to your business model, into a client in full Technicolor on the mobile device that increasingly we all want to play with now is kind of, as I say, a massive missed opportunity. So we were trying to figure out why we keep having such bad luck with mobile clients and what the kind of issues are, and what you would do if you decided to go off and generate a mobile client. And I guess one of the key things is that the mobile environment isn't like the desktop, the laptop environment, where we've got huge batteries and power and always on, always works, right? The mobile vendors value the consumer perception of their device based on things like battery life and the lack of intrusive notifications and things like that. So they're really keen on maintaining the value of the neighborhood, and they're not keen on you parking your bike outside the front door or whatever, because they really want those mobile applications not to impact on the consumer's sort of perception of their device. And the problem is, when we start going off and writing mobile clients that assume that the device is always on, so, for example, raw SIP isn't great from a mobile point of view, and it isn't great from a mobile point of view for reasons like this. So I get my mobile client comes along and it registers with the SIP registrar. And then, days, hours, months go by and tumbleweed rolls across. And of course, what happens is that the mobile platform wants to put the whole lot asleep to maintain that battery life. So my application really is properly asleep now, and then an invite comes in, because SIP wants to assume that we've got an always-on environment. This stuff can happen. And one of two things happen. Either I've conned the mobile platform to maintain a wake clock, to make sure that I'm awake enough to be able to receive that. And there's kind of an arms race between the mobile platforms and software developers to kind of from a software development point of view, allow us to always be responsive in that way, or from a mobile platform point of view to make sure that apps damn well go to sleep so they can't impact on battery life. So that's one of the kind of problems around SIP. Now, of course, there are solutions for it. Mobile vendors want us to use platform push notifications because they can be implemented in a battery efficient way. The mobile OS can kill your application right off, but then a push notification can cause it to come back to life and be able to deal with the message or the incoming communication that you want it to deal with. Maybe not as quickly as you would like, and that's one of the issues that we come across, but it exists as a mechanism. So if you want to layer that on top of SIP, you end up building something like this, where you put a proxy in the middle, you have your actual SIP registrar, your proxy holds the credential database, so it knows the credentials of all your clients, which, you know, okay, that's got some value, and then the client comes along, it registers with the proxy rather than with the actual SIP registrar. Time goes by, mobile goes to sleep, invite comes in, but it hits the proxy this time, and the proxy knows about the push notification endpoint, the push notification token for each of the clients that it has attached to it. So it sends a push notification to the mobile app. Wakey, wakey, mobile app comes up. Now it's got a bit of work to do, because if it was right down hard, the app is probably so asleep now that it's lost the knowledge of the fact that it even got a SIP registration. So it perhaps re-registers. Once it re-registers, we send the invite along, and our entire phone call proceeds. That's great. There can be some issues around that. One of them is that you've got to hold your SIP credentials in this database here. If that's all within your perimeter, and I guess that's no problem because you've got a SIP credential database and you know the whole lot is sitting within your perimeter. But quite often, you know, particularly if you're a smaller provider, you might be looking at using the vendor of your mobile app to do that piece for you, because again, the way that the push notification registrations work, really, you know, they're designed for a kind of a WhatsApp or a centralized service. So you've got one set of tokens for the service. So, you know, that's a perfectly good way of intermediating SIP, but it does have some drawbacks. It means you've got to outsource your credential database and have your customer SIP details sitting inside a third-party database to be able to manage the push notifications. Other problems, SIP credentials in lots of environments tend to be quite long-lived, so you're pushing those down to mobile. That is a source of compromise there, and in a lot of environments it's about as easy to monetize a set of SIP credentials as it is to monetize a credit card number. So the idea of these credentials sitting down there in a platform that you maybe don't control isn't a terribly good thing either. One of the other problems that we have with many mobile clients and mobile environments, we know WebRTC, we love WebRTC, and the whole ICE stun-turn stack makes it really quite not easy. That's an overstatement, but it makes it relatively easy to get media to a lot of places, including, you know, multiple levels of carrier grade NAT. So you've got 2 layers of NAT and all of that kind of thing. A lot of the conventional mobile client world is still stuck in well, a bit of stun and some symmetric RTP will sort that out for you, and it does it does allow us a certain level of connectivity. But wouldn't it be nice if we've got a mobile client that could do full-blown ICE and take some of those residual problems to get us from a, you know, kind of a 97, 98% connectivity to a kind of a 99 point by having the full kind of WebRTC ICE stack there. So they were the kind of problems we were trying to solve. Let me talk a little bit about our environment and the stack and the architecture that we were trying to put a client into. So we have this architecture that we developed for WebRTC based clients, and the architecture essentially has these kind of 2 main components. We've got a REST and WebSocket API, and then obviously the SIP registrar that sits at the bottom, and the SIP registrar is asterisk, and then the stun-turn server. But the API and the registrar share an ephemeral credential database. So those SIP credentials only really get created on the fly. They're not long-lived. Each login, each instantiation of a SIP client creates a new ephemeral set of credentials for that. And we have ephemeral turn server credentials, not quite as ephemeral, but they're churned slightly less frequently. But a login process in our environment effectively just starts a WebSocket listener. So we log in, we start a WebSocket feed. The WebSocket feed gives us all the info that we need to run a full WebRTC client. So rather than doing, for example, BLFs through a SIP notify type mechanism, we're doing all of that kind of knowledge of what's going on the platform, what's going on with my own client, what's going on with other people's clients, who's sending me chat messages, whether I've got incoming video requests. We're doing that through a WebSocket stream because that's way more efficient when you're scaling this thing out to thousands and thousands of clients. And then for getting the SIP credentials, we have effectively a credential get, which drops a set of ephemeral SIP credentials into the shared database with the SIP registrar. And at that point, the client SIP stack, because we're running a JS SIP stack in the client underneath it all, can then register against the registrar, and we can potentially get a conversation going by an invite coming in, and because we've got the turn server there, we've got the whole full 9 yards of ice. So that's the kind of architecture that we really want to replicate onto a mobile client when we set off at the start of the project. And can I give you an idea why we want to replicate that and it's important? That's the source code from our API for that whole process that I just talked through. So it literally starts with setting a server that we're going to talk to, logging into that server, starting a WebSocket feed. Once we started the WebSocket feed, we'll find that we've got an array of lines of SIP sessions that we potentially got, and we just call enable RTC on one of those, which is the thing that goes and sets and fetches the set of SIP credentials that we're going to use ephemerally, and then we register a set of listeners. So on this example, I'm just using incoming calls, so I just set a listener on what to do when I get a ringtone coming in, when I've got a call coming in, and what to do when a call comes up. So when I get a ring come in, all that I do is set off a ringing session and say call.talk. So I've got my call come in, and I'm just immediately going to say, yep, I want to accept that. Obviously in a real UI you would do other stuff like give the user a choice about that matter or something like that. And then my second case is when I do a transition from anything to up, then one of the things that I get is the remote media from the app session. So I grab the remote media, and this is from a React type environment, which is the environment we're implementing in the mobile client. Once I've got my my up media, I just attach it to my video tag and away we go. So one of the design goals for this whole thing was to be able to replicate this environment, this API, but in a mobile environment where we can do push notifications. We just hide all that stuff underneath this so that an app developer can just go off and develop a mobile client without having to worry about all this stuff. And the obvious way to do it is, okay, let's take that proxy trick and we'll just throw a proxy down on top of the REST API, on top of the WebSocket connection, and on top of the JS SIP talking to SIP registrar, and we'll just have it do the push notifications, right? So kind of figured, yeah, let's give this a go. We need a technology to develop this in. So tech choices, obviously the first one you develop in a mobile client, conventional wisdom is nothing is good as a native mobile app, right? There are some problems with that. First one, and the biggest one, meant that that entire JavaScript API that we developed, we've got to toss it away and we've got to re-implement it in, sort of Objective-C or Java or Swift or Kotlin. And we've got to do that twice because we've got to do it once for each platform. And the frustration, the kind of the business need for a mobile app, we were kind of on the point of saying, look, guys, we've got to go off and do this. And it kind of turns out you need, a huge team of people with complementary skills. There are people out there who can do both, kind of Objective-C and Java or Swift and Kotlin. But the reality is that to develop mobile apps, you do need quite a multidisciplinary team, and it's a lot of effort. That and the fact that it meant we'd have to toss our beautiful API away, and we'd end up with something that was complicated to the extent and develop against meant that that wasn't really something that we were going to go off and do. So other choices, PhoneGap and Cordova. We dallied with this 2 or 3 years ago. Someone had done a WebRTC plugin for it, and we figured let's have a look at it. But really that hasn't got enough momentum behind it and doesn't appear to be being supported for real-time use, and there's some good reasons for that. It's actually quite hard to get stuff in and out of it on platform. PWAs, that looked really interesting actually, so we figured, great, we can toss away the whole developing any kind of an app, and we'll just do a progressive web app. Service workers will listen on push notifications, kind of job done, and the whole API and the stack will work in that environment. That's all great. Reality is, it's actually not that easy to get the right data out of a push notification through a service worker and a PWA, and particularly on iOS. Although Safari on iOS does now have some elements of progressive web apps, push notifications aren't one of them. Seems to be a lot of agitation about push notifications within web apps anyway. I've heard sort of push death penalty and this sort of thing, based on the fact that it's perceived as being something that's being abused by kind of spammy apps. So it would be absolutely fantastic if we could build a PWA to do this, but we tried and didn't really succeed. Flutter looked really interesting. That's a new Google technology, newish. I think I'm not sure whether it's out of beta yet, but it was kind of announced about this time last year. It's not quite there yet in terms of all the things that you need to build an actual app. It's their sort of solution to the cross-platform development problem. And it involves yet another language, Dart, which again meant we'd got to move our APIs if we were going to go off and do that. And then there's React Native. We've been using React for some of our desktop-based applications, browser-based applications for a little while now, because it turns out the React lifecycle and the React model makes it relatively easy to take someone with React, which is quite a commodity web development skill, give them a real-time communications library and say just pass that down as props into your set of components, and we'll sort the API bit out, or we'll give you this crib sheet on the API and just build a set of React components that do this. So because of that, I figured, yeah, what the heck, let's go off and try using React Native for this. Just a really quick kind of top-level overview of React Native. The way that it works, you have a set of native modules which are compiled binaries that sit on the platform. The whole thing gets effectively built into a platform application composed of the React Native modules plus a JavaScript bundle. JavaScript bundle is where your application logic sits. So your React components that actually render your platform components and render your application. The life and soul of your application is this JavaScript bundle. And typically you'll bundle it for iOS, you'll also bundle it for Android, and the idea is that most of the cross-platform modules have one interface. They tend to have a few differences between the interfaces, the way the interfaces are used, because of the platform differences. But what you try and do is keep the choice of the modules and the way the modules are used as kind of cross-platform and platform agnostic as possible, and then that allows you to basically just produce these two binaries effectively for Android and iOS. There's also a third intriguing possibility, and that is that if you, in environments where you don't need those native modules, you can produce effectively an on-demand web app that runs on the platform, which is just Webpacked. So you could almost use React Webpacked or React Native Webpack to produce a kind of a PWA, and that was kind of intriguing to me because it was the possibility of producing a native application for both platforms, but possibly even a kind of kind of an on-demand web app. So we kind of toyed with that, and it turns out not to work too well actually. Let's talk about the implementation now and where we actually got to with it. So first thing was just putting together a simple one-pager app, just to really learn about React Native. Pulled in the API. The API hot loads from the provider from the service. So hot loading the API by pulling it in at runtime, figuring all that stuff out took about half a day, and by the end of it we got an iOS Android and web app that, you know, did something like change some forwards. I think it changed some forwards and turned a night mode on or something like that under user control. But that kind of convinced us that it was going to be a technology that was going to allow us to develop relatively effectively onto the platform. But once you get beyond a single one-page app, you start to need to worry about navigation. There are a few different navigation technologies in React Native. It doesn't provide a platform navigation apart from Navigation iOS, which doesn't give you Android. So you can use React Native's Navigator iOS, and that works absolutely fine, but that doesn't give you an Android solution. So you end up either hand knitting the Android solution or using one of the other technologies. React Navigation is quite good. What it does is takes the navigation model and delivers it in JavaScript. So it's actually implementing the navigation around the app as a JavaScript thing. And it's surprisingly good, actually, for what it does. But all that rendering's in JavaScript, so it's slow. And it doesn't look quite as native. You know, it's a little bit kind of PhoneGappy, Cordovery in terms of the way that it delivers that stuff. And then there's React Native Navigation. And that works quite differently, actually. So that's using the platform native navigation components on the iOS or the Android platform and then running each screen within it. So it gives you far better access to control of the app before the React lifecycle starts and things like that, which is quite useful when you're dealing with push notifications that potentially you need to do stuff before you've actually launched any React screens. So initially went down the React navigation path, worked quite well for us, and then tossed it out the window essentially to do React native navigation because we found we needed it for the push notifications, which is the thing that came next. Having got the navigation sorted out, next thing was pulling WebRTC and JSZip into the application. That was surprisingly easy, actually. There's a React Native module, React Native WebRTC. I think at the time it was sort of equivalent to Chrome M58. I think it's just been bounced to M63, which was good enough. Most of our API would quite happily run with M58. There are a couple of little tweaks to JSZip, which sits underneath the API, to deal with the slightly idiosyncratic way that the React Native module works as opposed to a real browser. So some of the top-level objects are a little bit slightly different in the way that they operated. And there's a really nice React Native module called In-Call Manager that allows you to do all the microphone control, ringers, ringing out, all of the detecting whether I've got the phone to my ear or not, and avoiding phantom presses from my earlobes. So that was just a straight bolt in, and I reckon probably a couple of days to get all of that up and running to a level where we were making and receiving phone calls, which was quite neat, actually. So whole API stack, the whole of JSZip, with React Native WebRTC, React Native Navigation, and we basically built a soft phone that was making and receiving phone calls. I was pretty happy with that. Next bit was implementing the proxy. So this is the kind of proxy model. You've got a proxy sitting there between the REST API, WebSocket API, SIP registrar, and pushing out platform native notifications. Choosing the technology for the proxy was sort of an interesting challenge. I wanted to build as much of the app as we possibly could in JavaScript, in fact all of it really. So the obvious thing was, like, let's have a look if we can corrupt JSZip, but it's not really a server. OverZip, which comes from the same guys that write JSZip, is Ruby based. I don't really fancy learning Ruby. Camaillio has a push notification module, and that seemed like a good possible choice, but wanted a bit more control in JavaScript. So we could do that by writing config files for it, but figured actually a better way of doing it was just run the whole lot in JavaScript and do our own direct control. Came across a really neat project called Dractio. Dave Horton just written this project that effectively does Sophia SIP stack under control of Node. So you get the real-time response of the SIP stack, but you're actually controlling the whole lot through Node. Went off and spent a good day trying to figure out how to use that in a WebSocket to WebSocket back-to-back user agent, and that kind of looked like we'd probably be able to figure it out, but we'd have to twist it out of shape. So gave up in the end and actually just used the npm SIP module as a bare kind of parser, and literally, that's what our handle server connection looks like. Handle an incoming SIP transaction from the server. If it's an options request, short circuit and send a 200 OK straight to the server so that we're not pushing that down to the client. If it's an invite, figure out if it's anything we can grok. If it is, then send a push notification to the client, send it to the client anyway. If it's anything else, just send it to the client. That was the first pass at it. Obviously, it's become a little bit more complicated than that, so we're deduping it and things like that. But doing WebSocket and SIP doesn't really need a full-blown proxy, because you've got a TCP connection. You're just really watching the messages go by and cherry-picking them in this kind of context. Push notifications, iOS is built into React Native, and we used a push notification client, React Native push notifications, that appears to work there, although they have some problems with the transition from GCM to Fire-based messaging that I'm not going to dig into at this point. So I'm kind of running out of time, so what did we learn? Superficially, React Native is really good actually for building this kind of client quickly. But when you actually dig into it, kind of under the hood, it's actually also really hard. As an example, the JavaScript deploy debug cycle is just beautifully easy in React Native. You sit there, you write or you modify a component, you've got hot reload, it re-renders, you want to debug it, you debug it in Chrome DevTools. So it's a cycle that any web developer will completely understand and be able to work with. On the downside, the debugger uses a different SIP engine running it, a different JavaScript engine running in a different place to the production build. So the production build uses Facebook's JavaScript interpreter running within the native engine. When you're running it in a debug environment, it's actually pushing the JavaScript out to the browser, running it in the browser's debugger. So you're running V8 when you're debugging and using an entirely different JavaScript interpreter on in the production environment. That makes it absolute murder to try and debug runtime issues that are related to the JavaScript engine. So you end up rolling back to kind of pinhole console.logs that are coming out of platform native debuggers to work out what on earth is going on when things don't work the same in both environments. And just things like if the time drifts between the emulated DevTools and the client itself, then you end up with a set timeout 0 taking 20 minutes to run, which is really quite interesting. So it's definitely a viable way to run apps, and it does save time, but React Native isn't quite as mature as you might think, particularly related to some of the real-time stuff, which makes it somewhat harder. Push notifications definitely work in this environment for inbound alerts, and that's definitely something that can be taken forward and run. I think there's some scope here actually for taking the learning out of that and building a platform, because I think there's so much kind of learning and putting this stuff together. Using it for exactly one application is something that I think isn't a waste, but it would be nice to open some of this stuff up. So next steps of the project really are, we've raced forward with it to a point where we've got working out, but actually the design suffered. So the next thing is to draft in those kind of React web developers to get us back on track with some of the usability of it. Proxy needs to scale horizontally. At the moment it doesn't. It holds a lot of the state internally in memory, which is great given that some of it is credential based. But we need to figure out a proxy that we've put a load of about 1,000 clients through the proxy, and it kind of works fine, but we've got to figure out a way of scaling it horizontally. And I think there's definitely a prospect of turning it into a self-contained proxy, a self-contained project, kind of like Expo, but for real-time communication. Expo is the bundled React Native engine where you can become a React Native developer without actually even building a client. You just bundle a JavaScript bundle and drop it into Expo, and it provides you with something that runs on any mobile, and you can run a client. So I think there's some scope within this project to kind of de-IP Cortex some of it, pull JSIP out from under the API and build a kind of like Expo but for RTC. Slides for the presentation are at that URL there. The project is at my personal GitHub on React Mobile. You won't be able to access it right this very moment because it needs my 2FA key that's sitting in my hotel room safe to unprivate the project, but give it half an hour and you'll be able to access that. I think I'm kind of out of time and I'm about to be yanked off the stage, but if anyone's got any questions, maybe I'll take one or two.
All right, any questions while we're waiting for our next speaker to come up?
I'm Zoa. I'm one of the guys working for Zuiper, the soft phone, mobile soft phone as well. In the beginning, you showed something for what is it called, the registration database or a credential database?
Yep.
So we had exactly the same concerns as you probably have. So we have a few million users. And we really were not too confident storing a few million credentials for the users on some of our servers because we don't have bank-like security, and sooner or later we would get hacked.
Yep.
So this is the reason why for a very long time we didn't have any push support. Now we went for a different solution for that. Instead of using a credential storage somewhere, we are using some sort of an outbound proxy. In this case, we're using Camalio. And we force a long re-registration time on the SIP client. And so, and because of that, we only need one push notification a month to keep us alive.
Yep.
And so we listen when the registration will expire and do a silent push in the background, and the client will actually re-register.
Yeah.
This is the alternative we used for it. Now, it sounds very simple. That's also what we thought in the beginning, but it took us, I think, a year to do it.
Yeah, this stuff is, you know, and I'm actually, we got into this, started white labeling Zuiper actually, and your product is fantastic. So, you know, from that point of view, we do both actually. So in the code for this, we've got the ability to proxy register, in which case, but that credential's ephemeral anyway, so it's flying past us. You know, we hold it for a short period of time. But actually, we found we didn't need that. We took exactly the approach that you guys. So if you do a long registration timeout and you force the client to re-register with push notification, then you don't need to see the credential. That's absolutely right. And actually, the production environment that we're running at the moment doesn't require that the credentials are actually stored. So we actually see them on the way through because we proxy the API request, but we don't then actually use it for the register. We just let the client register pass through. And then we obviously proxy the option pings, or rather, you know, kind of trombone the option pings so that they don't go as far as the client, so we keep the connection alive. But yeah, absolutely.
All right, big round of applause for Rob Pickering.